important. We'll go ahead and kind of get started. So thank you. I do see that several of you are recording, so I appreciate that. Let me get my screen sharing up. Okay, so the first thing that I want to do is simply want to ask you guys, hang on just a second. The first thing I want to do is ask if you guys have any questions from the 10.3 video. Do you have anything at all that you need to ask from the 10.3 video? Embedded questions should be in by now. Are
there any for that one?
Sorry, no, not for 10.3, but since we're covering 10.4, embedded questions should be in for 10.4 by now. Sorry about that. Yeah. So, any other questions? Nothing? Okay. So before we get started, and I'm also kind of hoping that maybe one or two other people can join. I just wanted to kind of set your all's minds at ease. I know that this is not the ideal situation, and it's not what we chose, but this is what has landed in our laps for the time being. And so I'm hoping that I can do whatever I can to help you guys out with navigating the system. If you have any questions of any sort, please, please, please just ask me either on text message or emailing or whatever, not even about class, but just anything about this. I can't guarantee that I'll be able to answer your questions, but I will do whatever I can to answer your questions to make this smoother for you. We don't go ahead, Drew.
You said that there are embedded questions due today. Where do we turn those in at?
You can turn them in via email or texting, either one.
Okay.
Yeah.
I'll have to do that after then. I didn't know that we were supposed to turn them in.
Yeah, so that I sent out in the 10.3 either the 10.3 video or the that 4-minute intro video. So that's where that was. But right now we still don't know how we're going to do testing. That's the one thing that's kind of up in the air at this point. So we're still working on that. We don't know how everything's going to work. And when I say we, I'm talking about the math department and all of my colleagues. We are all trying something. There is video conferencing, which is what we're doing right now. We're using Zoom. There is video conferencing through D2L. And so we're kind of comparing notes to see which one is the better of the two options. So the one thing that I don't like about Zoom is that I get cut off at 40 minutes. And so what's going to happen after we've been on for 40 minutes, what I have to do is the meeting is automatically ended, and then we just have to go back to that exact same thing and just re-sign up again. It shouldn't take more than 30 seconds. But as we're navigating this, it's a little bit crazier. But so just so you know, we will get cut off for 40 minutes. But that's what I like about the D2L is that you get 240 minutes, and I'm so not keeping you for 240 minutes. But I do get that option of a longer class period. So, but there are some things about the D2L that I don't care for. So we're comparing notes. We're trying to figure out what we like best. So yeah, so that's kind of where we are right now. We're just doing the best that we can. I do want you to be thinking as I run today's class, my other Math 111 class, would rather have a video like I sent out for 10.3 and then use this Zoom and class time to basically have a time where you can enter the Zoom conference and you can just ask any questions that you have. So I don't want you to make a decision right this minute. but be thinking as I run the class time today, you know, which do you like better? Would you rather have an actual face-to-face class like what I'm about to run? Or would you rather have a video that you need to watch and then you can just enter the classroom if you have any questions? If that's the route we decide to take, then probably what I would do is I would only have it open for that first 40 minutes. And then once the 40 minutes times out, I wouldn't re-sign up, and just unless there are students who are in the middle of asking questions and we would need to continue that. So that's kind of where we are for right now. All right, so with that said then, do you guys have any questions before I go ahead and jump right on into section 10.4? And I think somebody told me yesterday, if your microphone is muted, which is fine because it cuts out the distracting noises, I think all you have to do is push the space bar to speak. If you guys can confirm or deny that, that would be great. Anything that you learn, is that what, okay. So anything that you are learning, folks, I am learning. So the more that you can give me, the more info that you can give me, the better it is. So any questions before I just get started on 10.4? All right. So if you have questions, just stop me. By the way, Drew, did you hear from Mert?
No, he didn't respond.
Okay, that's fine. Like I said, it's being recorded, so hopefully that'll work out, and I'll be able to, hopefully it'll work out better than it did yesterday. All right, so let's just start right in on section 10.4. I opened the video with an embedded question, so let's go ahead and just do that right off the bat. And so you'll notice that from the video, I was taking the inverse and rewriting it as something normal. Get used to doing that because we're going to do that throughout this whole entire section. So if I want to take then the cosecant inverse and rewrite it as something normal, then that is just simply going to be y is equal to the cosecant of theta. Let me shift that over just a hair. And then the same thing for secant inverse. That is going to be y equals the secant of theta. And then for cotangent inverse, that's going to be y equals the cotangent of inverse. Let me shift those over just a little bit so they're not running into that symbol. One thing that I want you to notice is that when I write it in inverse form, whether it's this guy or whether it's my original 3, it is my theta that is standing alone because inverses find angles. We've actually been saying that for all semester long, or at least since chapter 9. And so theta is my angle, and then my trig of my angle, so in this case, it's the sine of my angle, is equal to the y value. So that might not mean anything to you right this minute, but in a few minutes, it's going to mean a lot to you, especially when I want to take that inverse concept and rewrite it as something normal. Okay, we had some restrictions that I gave you on the video. So just a comment really quickly on restrictions. So, and by the way, I do want feedback from you. So I don't want this to just be a time where I'm the only person speaking. So please chime in whenever you want to. Let's say that I have something like the value 11 pi over 6. Okay. When you look at 11 pi over 6, it totally looks like it meets the restriction for the sine inverse, the cosecant inverse, and the tangent inverse. I mean, it's in that colored space there. It's on the right-hand side of the circle. But if you go over to the number line version, and if you think, if you think about where 11 pi over 6 is on the number line, 11 pi over 6 doesn't occur until right before 2 pi. And what you see there is that 11 pi over 6 is totally not in that restriction that was handed to you. So that's a really important thing to grasp a hold of, and you'll see more when we're doing some examples. But in order to meet the restriction, basically what you need to remember is that the name of your angle has to be a quadrant 1 name, just with a positive or a negative value. So we would say that we can use any quadrant 1 angle name, or we could use a quadrant 1 angle name just with a negative on it. So instead of calling that 11 pi over 6, what would we need to call it to meet the restriction? Matt, what do you think?
Pi over 6.
So pi over 6 would be in the first quadrant, and it wouldn't be in this same spot. What would you need to name it to be in that same spot, but still have a quadrant 1 name?
Pi over 3.
No.
Negative pi over 6?
Yeah, it would be negative pi over 6. So just think about the fact that when I go to the first quadrant, these all have normal first quadrant names. But then when I go to the fourth quadrant, I need to use the negatives on those quadrant 1 names. Does that make sense, guys?
Yeah.
Okay. So, and then secant, cosine, and cotangent, these all have just the top half of the circle restrictions. This is actually going to be the easier option to be using. All right, let's just jump right on into example number 1. And let's pay attention, first of all, to what the directions say. So it says, find the exact value. Okay, we already know what exact means. Of y in radians. No calculators on these. Now, so we're working in radians here. Let's just talk about my sticky note tips. Write it normally. Okay, so don't use inverses. Secondly, use your unit circle. Folks, right now you should have your unit circle out in front of you. We're going to use your unit circle all day long, or at least all session long. And then what you're going to do after you use your unit circle, cut out any solutions that don't meet the restrictions we just talked about. Now, one thing that you see here that's totally different, like example 3 and example 4, look at those two. Those are inverses like we just wrote down or like was written down in your notes video, but example 1 and 2, they look funky. There's that arc thing in them. What you need to understand is that arc is the exact same thing as inverse. They are synonymous. They are no different. So when you see an example 1 and it says arc sine of negative root 2 over 2, arc sine is the same as sine inverse. Okay, so just understand those are exactly the same thing. Okay, so let's just jump right on in. And the first thing that my sticky note says is that I should write this normally. So not with a sine inverse, we want to write it normally. So we want sine of my angle, sine of my angle is, my angle here is y, is equal to negative root 2 over 2. Okay, sine of my angle is equal to negative root 2 over 2. So sticky note tip number 2 says, use your unit circle to figure out where all of those places are. So let's go to our unit circle. Where are all of the places that sine is equal to negative root 2 over 2?
5 pi over 4.
Okay, so 5 pi over 4 is one spot, which is going to be right here.
7 pi over 4.
Good job, 7 pi over 4. Very well done on both of those. So, okay, so then tip number 3 says that we should compare with our restrictions and throw out anything that doesn't meet the restriction. So when you're looking at this, what is the sine inverse restriction? Is it on the top half of the circle or is it on the right half of the circle?
Top half.
Sine inverse?
Never mind. The right side.
Good, good, good. So it's on the right side of the circle. So so when we're looking at it like this, we need to throw out this guy because it does not meet the restriction. Okay. Now you told me that that value was 7 pi over 4. But the question is, does that value meet both restrictions? Yes, it's in the right side of the circle, so it looks like it meets that, but does it meet the number line side of the restriction? Come back up. 7 pi over 4 is smack dab in the middle of this quadrant. So does it meet the number line restriction?
No.
It doesn't. So what do we need to call 7 pi over 4 to make it a legitimate response or a legitimate angle?
Negative pi over
Pi over 4.
Very good. Negative pi over 4. Okay. All right, let's jump into example number 2. Okay, so once again, we want to write it normally. So can you guys tell me, how should I write this normally?
Tan y equals -1.
Good. Okay, so that's written normally. Now let's go and find all the places on the circle where my tangent value is equal to -1. So where is my tangent value equal to -1?
3 pi over 4.
3 pi over 4, very good. And where else?
Seven pi over 4.
Yeah, 7 pi over 4. Okay. Now, number 2, we found all the positions. Number 3, where are the restrictions for tangent inverse? Where are the restrictions for tangent inverse? Are they on the top half of the circle or the right half of the circle?
Top half.
Right half.
Uh-oh, which one? Go look at your first page of notes. Tangent inverse restrictions. Sorry, I have a crying dog right now.
So that'd be the right half.
Good, it would be the right half. Okay, so then we could say that this is y equals, you said 7 pi over 4. Oh, well, apparently I'm stuck on this 7 pi over 4 concept. Instead of calling it 7 pi over 4, because we know that won't meet the number line restriction, what do we need to call that?
Negative pi over 4.
Pi over 4.
Yeah, negative pi over 4. Okay. All right. Now, there's a couple of you I haven't heard from. So just chime in, please. Yesterday, I started calling on people. So just feel free to chime in. Okay. So somebody who hasn't answered yet, tell me how to rewrite number 3 normally.
Cosine y equals 1/2.
Very good, Bryce. All right, cosine y equals 1/2. So then we're going to go to number 2, which says find all the places on the unit circle where this is a true statement. So somebody go to your unit circle, somebody who hasn't answered yet, and where are all the spots where we have a cosine value that is equal to a 1/2?
Pi over 3.
Good job. Pi over 3. And where else? Anybody?
5 pi over 3.
Yeah, 5 pi over 3. Good job, Daniel and Sarah. Okay, so pi over 3, 5 pi over 3. Now let's go look at our restrictions. Where are the restrictions for cosine inverse? Top or right?
On the top.
Yep, on the top. So let's throw out the 4th quadrant guy. Okay, now pi over 3, let's go back to our number line. We know that pi over 3 works for my picture. Does pi over 3 also work on my number line?
Mm-hmm.
Yeah,
Yes.
it does. It does. So then we can keep the answer of y equals pi over 3 for that. Okay, let's look at number 4. Let me fix my square root here. My symbol got shifted. Okay, so let's write it normally. So this is going to be the secant of y is equal to -√2. Oh, but there's a problem. Remember that I haven't memorized secant values. Oh, but who is secant's partner in crime?
Cosine.
Okay, cosine. So, hang on a second. Hang on. I just accidentally hit the wrong thing. There we go. Okay, so it is cosine. So what is cosine and secant's sorry, I got distracted by the fact that I only have 9 minutes left. What is secant and cosecant's relationship to each other?
They're inverses.
Wait, don't use that word. No, they're not inverses.
Reciprocals.
That's the better word. Very good, Matt. So they're reciprocals of each other. So if secant equals negative root 2, what does cosine equal?
1 over negative root 2.
Very good. And I'm going to go ahead and rationalize the denominator mentally on that, and I'm going to get a negative root 2 over 2. Okay. So this is a normal value on my unit circle. So let's go back to the unit circle, and where are all the spots that cosine has a value of negative root 2 over 2?
3 pi over 4.
Okay, 3 pi over 4 is one spot, and where else?
5 pi over 4.
Yeah. Now, what are my cosine? I'm sorry, I don't want to ask about the cosine inverse because my original was a secant inverse. Where are my secant inverse restrictions? Top half or right half?
Top half.
Top half. So throw out your third quadrant value. Y then is equal to 3 pi over 4. And that also meets the restriction for the number line value. Okay. All right, now, can you take a look at the next set of instructions on your notes? How are these guys different?
We're in degrees.
Yeah, we're switching over to degree values. Okay, and we're switching over into thetas instead of y values, but no big deal there. We've switched variables a whole lot. So somebody tell me how to rewrite number 5 normally.
Cosine of theta equals negative 1/2.
Good job. Cosine theta equals negative 1/2. All right, so go to your unit circle. Where is my cosine equal to a negative half? Bless you, I think.
2 pi over 3.
2 pi over 3 and
4 pi over 3.
4 pi over 3. Okay. Think about your cosine inverse restrictions. Which one should be thrown out?
The bottom one.
Okay. So then are you going to write down theta equals 2 pi over 3? Why?
Because we're in degrees.
Because we're in degrees. Good. So what are we going to write down?
120 degrees.
Yeah, 120 degrees. Okay. All right. We've got 6 minutes before we time out. So can you guys see that counter up at the top, or am I the only one who can see the counter?
I can see it.
I can't see it.
Okay. So let's look at number 6. Can you rewrite number 6 for me?
Sine of theta equals 0.
Okay. So let's go to the unit circle. Where is my sine value equal to 0?
90
degrees.
70.
Sine value is my y value.
Oh.
0 degrees.
Yeah, 0 degrees. And where else?
And 180.
180.
Yeah, 180. And really at 360 as well. So then what are my sine restrictions?
The right half.
Okay. So then my theta is equal to?
0.
0 degrees. Question, would I also include the 360 in that?
No.
Because that's outside of the number line.
Good job. It's outside of the number line, so no, I would not. Okay, so let's take a look at number 7. Okay, so let's write it normally first. We have cosecant theta is equal to negative 1. Okay, so cosecant isn't one of the ones that we've memorized, but whose partner in crime is cosecant?
Sine.
Yep, so we've got sine of theta is going to equal the reciprocal. So what is the reciprocal of negative 1?
Negative 1.
Negative 1. So where does sine equal negative 1?
270 degrees.
Okay, so are we going to write down theta equals 270?
No.
No.
Okay, so what are the restrictions for cosecant inverse? Top or right?
Right.
Okay, so it does look like in this picture that it meets those restrictions, but what's wrong?
It's
It
not
doesn't
the
use
number
the
line.
line.
Yeah, good. So let's not use 270. What do we need to use?
Negative 90.
Negative 90.
Good job. Negative 90 degrees. Okay. All right. Let's do a cotangent. Of all of the ones that I've given you in this section, this is probably the most challenging. Did somebody have a question? I'm just kind of plowing ahead. I'm assuming just in class, you'll just stop me if I have a question. Okay, so let's go ahead then and write it normally. We have cotangent theta equals negative root 3. Okay, haven't memorized cotangent. But let's ask this. Where is cotangent negative? In which quadrants is cotangent negative?
2 and 4.
2 and 4.
Yeah, okay. Now, we just got finished doing a tangent inverse question where my tangent value was equal to 1 or negative 1. And we knew that that was going to occur smack dab in the middle because that's when my y value and my x value are identical to each other. Well, I know this is not going to be at one of my 45 spots because the cotangent does not equal 1 here. So that only leaves 2 possible spots in these quadrants. Okay, so remember cotangent is my x value over my y value. So I need an x value over a y value that's going to give me a root 3. So we've done this before. Both of these have the same x and y values, just traded. So we could say, well, it's either going to be root 3 over 2 over 1/2, or it's going to be a 1/2 over a root 3 over 2. Now, you guys have probably memorized which one it is. This is the guy that gives me a root 3 when I invert and multiply. Okay, so then if this is my x value and this is my y value, because cotangent is x over y. So we're about to time out for the record. So we'll finish this one up. Can you go ahead and finish this one, and then we will jump right back into this one and finish it up when you come back. So finish it on paper, and then I will be right back.